I'd like to start by talking a bit about object-oriented programming. Now don't worry, this isn't a programming class, but I think that it will help to understand a few of the key concepts of how object-oriented programming works in order to better understand how things are set up in Unreal. You see, Unreal is built on an object-oriented programming language called C++, so everything that exists in Unreal is based on this language. So, what is object-oriented programming? Object-oriented programming is a programming paradigm that organizes code into objects, which are instances of classes. It provides a way to structure and design software by representing real-world entities and their interactions. Object-oriented programming focuses on creating reusable and modular code, making it easier to develop and maintain complex applications. It affords many unique benefits, but we're going to focus on three: classes, objects, and inheritance. A class is a blueprint or template that defines the properties and behaviors of objects. It encapsulates data and functions into a single unit which can be referenced later. An Unreal actor is an example of a class. When you create a new blueprint actor, you're creating a new class based on the actor class. In fact, pretty much everything that exists in the content browser is a class. It exists with variables and methods unique to itself. Objects are instances of classes. They represent individual entities with unique states and behaviors. Each object has its own set of data and can perform actions based on the defined methods of its class. The object is where you will assign the various properties of the class specific to the object itself. So, when you drag that newly created blueprint into the level that is open, you're creating an object or an instance of the class that you created earlier. You can then assign its various variables specific to this object. Just as we as humans inherit genes from our parents, class inheritance allows classes to inherit properties and methods from other classes. It enables the creation of hierarchical relationships between classes, where child classes or subclasses inherit characteristics from its parent class. This promotes code reuse and facilitates the creation of more and more granular classes which inherit attributes from more broad classes. When you create a new actor blueprint, you're actually creating a new child or subclass of the actor class. Your new blueprint is inheriting all of the functions and variables that already exist in the actor class. When you create a child of the actor class, you get access to all of these unique functions and variables, as well as the ability to add unique functions and variables specific to this child class. From there, you can then create a child class of this new blueprint, which can then add even more granular functionality and available variables. You can do this as many times as you want, getting more and more granular with each subclass. Let's take a look at an example. First, let's create a new blueprint actor class. And we're just going to call this BP actor parent. Now, if we double click on this and open it up, we can go to the event graph and we can see we can add functions. We'll add a new function called parent. We can add variables. We'll add a new variable called parent string. And we can set these to whatever we want. And then we can utilize the function. Now, if we want to create a new child class, we can go back to the content browser, right-click on this blueprint, and create child blueprint class. The other way you can do that is to right-click and create a new blueprint class, and under all classes, search for BP actor parent, and choose that. Let's call this one BP actor child. Now, when we open this up and go to our event graph, we can see that these functions and variables don't exist over here from our parent. However, if we go to our class defaults and look over here on the right, we can see our parent string exists here, and we can assign it. And if we right click and type in fParent, you can see that we can call the function from our parent blueprint. Now from here, we could add a child 01 function. And we could add a child boolean. Now, why is this important? Why would you want to do this? The whole idea here is to inherit from a more generalized blueprint, and then as you get more and more granular, you add more and more functionality. That way, if you need to change something higher up in the hierarchy, you can do so, and it will trickle down to all the children that inherit from the parent. So if I wanted to, I could now create another child blueprint class, call it BP actor child 02, and now you can see I am inheriting from the parent class. I can call this one a different string. I can still right click and utilize the parent function, but I can set up a new function called function child02 that does something different than what child01 does. I can set up a different type of variable that does something completely different for the child02. Now from there, we could then right click on this child01 actor and create a child of that. We could call it actor child of child 01. So now this particular actor is inheriting from this child actor and is therefore inheriting from this parent. So not only do I get the functionality of this child actor, but I also get the functionality of its parent. So now if we open up the child of the child and right click, we can see we have the parent functionality and we have the child functionality. In the class defaults, we have this child boolean variable we can set and the parent string that we can set. Then we can add a function for this particular one. And a variable for this particular one. Then we could keep going. We could make a child of the child of the child. We can keep going on and getting more and more granular as things go on. All of these will inherit from this parent. All of these child of childs will inherit from this also. And then if you made another one, it would also inherit from this. So you get all of the functionality moving down more and more granular in inheritance. Now we can also do this with widgets. So if I right click and create a new widget, we can make this the user widget type and call it W example parent. And when I open it up, I can go to the graph editor, create a new function called fParent, and create a new variable called parent boolean. Then if I create another new widget, I can choose a parent class for this. If you're using Unreal 427, you can only create a user widget. You can't actually inherit here. But I'm going to show you how you can do so in 427. So in 5 and later, we can now type the name of it and create it here, and it will inherit now from this. We'll call this W example child. And if we open this up and go to the graph, we can right click and call fParent. We can also go to our class defaults and see under default, we can set the parent boolean. And again, this will allow us to make a new function called child01 and child string variable. And this functionality now exists only from the child, but it still inherits all of the parent's functions and variables. We could make another one by right-clicking widget, search for our example parent widget, and now this could be example child 02. And now we still have the parent functionality and the parent boolean, but we can create a different function and a different type of variable. Now, what if I wanted to do this in 427, or in 5, what if I wanted to change what the parent for this widget is? Well, in that case, all I have to do is come to File, and you can see down here we have something called Reparent Blueprint. If I click on that, now we can search for W child. So I can actually make this now a child of this child of parent. And you can see that this can cause problems depending on if you're utilizing the parent's functionality or not. If you are, it's going to remove all of that functionality because now it's not going to have that functionality. So now that I've reparented it to the child, you can see now I can also call the child's functionality, and I can utilize the child's information. So that's how we can reparent a widget to a different parent. So moving forward, we're going to be utilizing a lot of these different concepts from object-oriented programming to create our dynamic menus and our complex inventory system.